My name is Chris Mokunya. I'm a security analyst. And today I'll be taking through an amazing session. Just a moment. Yeah, today we'll be looking at DevSecOps Unveiled, how we can integrate security in the development lifecycle. Because as we know, security is quite a crucial thing when it comes to development, right? So, yeah, that's what we'll be talking about today. So, I need to cue this in. Yeah, this is me. I'm a security analyst, and today we'll be looking at DevSecOps Unveiled, which is basically what we'll be talking about the how we can integrate security in the development life cycle, basically, which is all the talk. What is all the talk today is about. Okay, so yeah, DevSecOps. So I know it's quite a big thing, especially in the latest trends in security. You find that DevSecOps looks like a big buzzword that we've been talking about. So, but basically, DevSecOps basically adding security to the DevOps life cycle. So you have the DevOps cycle, you have the development cycle whereby you have the developers, you have the deployment, you have the, but then we add a layer of security so to make it more secure during development, which helps to save time when deploying and producing. So this is the basic. So here we have the basic overview between DevSecOps and DevOps. So in the DevOps, you have your basic plan, you have the build part, and then from the build, you have the testing phase, and then you have the releasing phase, you have the monitor, and then operate and deployment phase, basically. So, yes. Oh yeah. Uh, good, good. Sorry about that. Slight technical issues. So in the development, in the DevOps normal DevOps procedure, we have the whereby you have the you start with the plan, and then you have the building phase, the coding, the planning, the testing phase, releasing, deployment, and then operation phase. But now when now we talk about DevSecOps, you can find that we had a little bit layer of security. So that when you find now when it's the building phase, so whenever you're at the building phase, where basically you try to talk about the product you're trying to build, you try to start brainstorming on which are the possible security issues that will come along. When it comes now to the code, you'll be looking at things like static code analysis, dynamic application testing, and then whereby you now can get to look at the code for vulnerabilities by tools like Snake, I think SonarCube, that's where they come in. But you can now be able to do inline code scanning for security flaws. And then the planning phase, that's whereby you also get to talk about, in the planning phase, you talk with the security experts and you get to talk about which ways can this app be made more secure, because what are some of the ways that apps are compromised. You have the testing phase. This is whereby when you're testing the app, you get to look what common loops are likely to occur during the application. When releasing, you will need to watch your deployments, ensuring that whatever the release that you're giving is secure. In the deployment, you need to watch your deployment pipeline for any security flaws. Are you leaking any API keys? Just an example, things like, are you leaking any API keys? Is your workflow correct? Are you going to get like a massive cloud bill for no reason because simply you use the wrong deployment method, or maybe there's a misconfiguration in the deployment? And then from there, you do monitoring. These are your use tools like Grafana and Kibana. I hope I'm audible to everyone. Yeah, use things like Akina Grafana so to monitor your deployment. Then the operation, basically, just basically be looking at how is the app operating? Is it operating as it should be? Yeah. So DevSecOps is basically the fusion of development, security, and operation, whereby now we have development and security people coming together, and then we are able to talk about what is going on in the DevOps cycle. So basically, DevSecOps addresses and the concerns that you get through software development. because, for example, you have like something like a fun fact. Most of a good number of the hacks that have occurred, like software breaches that have occurred, they have occurred where there's a patch available. There's a patch available for the specific exploit that was exploited, but then it was not patched. So these are some of the things that DevSecOps look towards looking at. Is there vulnerability? Are you looking at your open source code, the open source dependency that you're having? Is there any vulnerability that is there? Has it been patched? Have you patched it on your production? That's what basically DevSecOps is all about. So some of the benefits of DevSecOps, these are basically derived from now the DevOps pipeline, whereby you get faster delivery, but now this one, faster delivery with security, because you can be able to remediate security fixes on the go, because if you are able to identify them on the fly and then fix them before, you can even go further. Because sometimes if you, in the normal DevOps pipeline, you find that development cycle, you find that whenever you fix your pipeline, you found a security issues after the release. Then you have to recall back the app, maybe take the system down, and then fix the bugs as you go. But in the DevSecOps, you're able to fix the security issues as you find them. So if there's an issue, fix it and then continue developing. So every stage of the development as you proceed, it's a step forward. You will not have to go back to look for security issues as you approach deployment. So you also get enhanced quality. This because you have things like code scanning, you have like deployment failure. So if there's a failure in deployment, to avoid issues later in deployment, you're able to check what is going on, and if something is a problem, the build does not go successful and stopped until it's fixed. So you also get the raw risk, because raw risk in some terms of your software, you find that whatever you are building, there is lower risk of getting some of these bugs shipped to development, because at every stage of your development, security was put into consideration. So you get to reduce the risk, and you also get efficiency gains. This is because this DLC basically means software development lifecycle. This is because it reduces for the need for time-consuming security reviews at deployment development. You find that on most cases, you develop an app and then you start doing code review first before you ship, and then after the code review, you then go towards testing the application for security flaws, which takes quite some time before you finally get to release it finally to the public. But the fact that you are doing all these tests on the go, you are able to minimize some of this risk in the software development lifecycle. Yeah, so we can look at a few principles of DevSecOps. I think there are around 7 principles of DevSecOps. So the first one is the shift left security. I think I'll just go into it and basically do have. Oh yeah, so this is the shift left security. You have the planning. In the planning, you have the security architecture put into place. When it comes to the coding, you are able to implement the secure coding practices. When it comes to building, you get the secure repository for dependency. That means you are able to monitor all the dependencies, whether open source or the commercial ones. You're able to monitor for security flows on the fly, and then you do the application security testing. This can be the DST, dynamic application security testing, or maybe the continuous application security testing. The next thing, you'll be looking at compliance. Different software have different compliance requirements. If you're building maybe a software for a health app, maybe you find that there's the FEPA. You also have the GDPR compliance. In Kenya, you do have the Data Protection Act. You're able to be looking at this compliance, whether you've been able to meet them as you go. And also have the ISO standards for certification, which are basically are able to talk about how good is your software. Then from there, we also have the secure pipeline. This is basically your pipeline for development, because you do not have to like build, you just have to push code, like normally you do, you push code to your GitHub repository. If all the checks are okay, it gets pushed to deployment and production instantly. So you are able to watch the pipeline and see whether everything is secure, so that if there is a bug, it is not introduced to the production. It is instantly fixed before the deployment fails, and that bug is not able to be pushed to production. So we also have the under operate, we have the AAA, authentication, authorization, and accounting. So basically, you're able to be looking who has access to these features of the code, what permission do they have, basically the principle of least privilege. You're able to give someone only the bare minimum privilege they need to do a task. If it's a developer should not maybe have permissions to maybe to be able to change the pipeline for development. Maybe it's like deploying to the cloud. A developer should maybe be able to, his task maybe after pushing to GitHub, or maybe whichever, what do you call it? GitLab, those, yeah, what do you call them? version control system, yeah, whichever version control system you're using. So you're able to be looking this, if it's a developer, what permission do they have from the code? Can they be able to push to production? Because as a developer, you'll be able to look at, this is a developer, let's him have the test branch, that's why you'll be able to push his code. And then there's someone, the senior software developer, his one will now be having the permission to authorize. This one can now go ahead to production. But then the developer should not be able to give the things like the real permission to deploy to production without having to have a review. It's something like pushing to the cloud, who has access to the identity access and management credentials, and what level of access do they have, the fine-grained authentication, authorization, and accounting. Then from there you have the monitoring, whereby you now be able to, in the accounting phase, be able to look who has access to this, so that in case of an issue, you're able to track who did this and what happened, and this is why we are able to get this issue. That's where the accounting comes into place. The next point, you have now the monitoring, where you have the incident response. In case of something, you should have a feedback and remediation for how to fix that in case of anything. So you should have a standby plan for how to go about it. That's basically the shift left security. The next thing we'll be looking at, we have the holistic automation, which is basically adopting end-to-end automation for extensive setting and CI/CD. This is the continuous integration and continuous development processing. So in holistic automation, it's quite important because it basically saves time. We are able to use tools like, I think, SonarCube. Most of these tools do fall into places whereby you cannot be able to test for your software components that you're using to ensure that they are up to par with what is required for security. Next, you have the continuous security testing, which is basically extending security to include automated testing functions. Is basically after deployment, you'll keep monitoring the application and the entire build process for security vulnerabilities, and also so that you can be able to fix them, because you have your dependencies. So that's why we'll use automated testing functions like dynamic application testing, and then you have things like SAST, and which help in ensuring the build is thoroughly analyzed for security. Okay, the next thing we have DevSecOps. This is the collaborative culture and communication. This is whereby you're basically trying to look at the security personnel. We have the DevOps, you have the developer, we have the QA team. We're trying to bring them together so that all towards building good software that is also secure. So this is what we call about the collaborative culture, because each and everyone is involved at each step of the stage. They're able to enhance the communication of all the teams that are involved in a software development lifecycle, the SDLC. Next up, we have security as code. This is basically treating security policies and procedures as code for automated workflows. This is whereby we have things like, it's getting hard. It's disappearing, but we have things like, I think Sneak is also among them, where basically we are looking at, when we are having Sneak with one of our sponsors, we're looking at things like, when in your code, what is there that is now being implemented? Is your code safe for deployment? Is it good to deploy? That's what we're basically looking at security as a code. And then we also have tools like SonarCube still comes into place, and we also have GitHub, Dependabot. Yeah, Dependabot does not do in real time, but if you do have it, the Dependabot, it also does the same thing. We also have Amazon Q, not really Amazon Q. I think Code Whisperer. Yeah, I forgot about the one for Amazon. Yeah, but basically that's the entire thing. So the next step we'll be having it, the traceability, auditability, and visibility. We're able to track. We have things like version control. We also have like code scanning, whereby you're now able to look in the documentation who worked on this code base, what did they do to the code base, what changes did they make, are they good for deployment? There's a security fix. Is it really a security fix? Because you now have to validate. Someone may be pushing software about a security fix. Is it actually a security fix? Is it a bug that has been introduced in the system? We'll be looking at now under the traceability, whereby you'll now be looking at everything that is going on in the entire cycle. You're able to look at it and present it. So next we'll be looking at continuous improvement. This basically security is an ongoing thing. So when it comes to security, you'll be looking at every time. You'll be looking at, are there new changes? We have new vulnerabilities that are coming out. What more can we do to make the user experience better? If not the user experience, the development lifecycle better, and maybe even faster. Yeah. So some of the best practices for DevSecOps, we'll be looking at shift the culture. Yeah, this is one of the hardest things basically because most of the time you find that in most cases you have a team working on an individual project and the only thing they'll be looking at is the project status and updates. So like whoever is your supervisor will be, have you reached on the project? I'm almost done, and until like you push your code, but they do not really have that much overview of what you're doing. So you find that it's quite a big deal because you have the person. So you find that the person who's supposed to be deploying is waiting for the developer. The developer is on this code base, maybe one is working on the front and the other back end. Find that it's quite a big thing. But now, whenever we try to bring now everyone together, security person, the developer, also get the developer to security cautious in their development. Because on most cases, find that I'm just the developer. Security is not really my domain, but it's actually everyone's domain. So we'll be looking at now the culture so that we can get now to look at how do we get everyone to work together to develop the software at any given stage. So if it's the developer, whenever we are like in the planning phase, the developer is aware of the security configuration that's supposed to be looked. Mid in while still developing, there's a security person who's there to look at what's really going on. Now that's all about the culture because on most cases it's like one stage, if there's an issue, back to the developer, and then a few more weeks. It basically delays the process. But if now we are able to now integrate everything all together, everyone is working at the same time towards on a project. That's basically helps save time and makes the development lifecycle better. So the other pattern is define our requirements and metrics. So basically this is all about establishing the minimum security baseline. So we do have a few industry guides that basically look at the security requirements. We have the common one, the OWASP top 10, the Open Workload Application and Security Project. So the OWASP top 10, which is basically a link. Can you open the link? Yeah, sure. So this is basically the OWASP project, which is, where is it? Oh, yeah. Oh yeah, the OWASP project. This is basically the top 10 most security vulnerabilities that do affect softwares during development. The other one, we do have the SANS top 25 software errors. These are basically mostly things like the logic bugs and things that developers basically fail to do when developing. This is some of the things that you can be able to be looking at before while developing. These are the metrics. So you'll be looking at the developers, the deployment guys, the person who's in charge of the UI UX, so that you can be able to put this into account. So are we secure from this? Are we solved it? Because at the end of the day, there's no need for you to go back to fix an issue that you could have overlooked it in the first place and developed without it. Oh yeah. So the other thing is starting small basically. You don't have to start big with some of the big expensive software and all that complicated stuff about security. You can just start small things like inline code scanning. It's just basically the basic one. You can do like inline code scanning and you'll find that it'll actually improve quite a bit because at the end of the day, your software you'll get a few alerts on things that you've maybe misconfigured, some of your functions not written to standards, and yeah, just as simple as that. You don't have like to have an entire team working around the clock on your software. You can just start small, and you get to do you get to build securely. So the next point is implementing automation. This is because when it comes to automation, is it saves time and you are able to catch errors that normal manual review cannot really catch. This is because you are able to configure the rules and some of the issues based on previous vulnerabilities. Comes to a human person, yes, it's good. It's always recommended to have someone do normal review. But then with automation, it helps to simplify the process and you can just write rules that basically will say if this condition is not met, do not deploy. Please cancel the build and give the developer a huge error until they fix it. Yeah, everybody loves bugs, so that's an extra bug for you for not building securely. Yeah. So by automation, you are able to do some of these things that help simplify the entire process. Things like scanning your containers, inline your APIs, see whether they're exposed or whether they're exposing credentials that things that should be exposed through API endpoints. Just with simple automation, you can just be able to check, write rules, and then check whether these things are met. Next up, we can do like threat modeling. This is basically whereby you assume you're an attacker and then what points of your software or product would an attacker be likely to attack? This is you now trying to think like an attacker. So what's likely to be attacked? We have maybe it's the login page, there's the payment system, someone does not want to pay, so they'll try to attack the payment system, see if they can crash it. We have the database. Can someone access the user's info, do things like the IDO, things like that. So that's all about threat modeling. When now you try to look at these things, you now try to see, have we fixed all these issues that an attacker may be able to look at? Are they fixed on our end? If they are fixed, then you go ahead and continue with the development. So how to fix them? If you find one of these issues that are there when you're doing your threat modeling, you now try to fix them, and then some of them are more critical than others. So you'll of course prioritize the critical issues, and then the rest go on as you go. Okay, I think I did do this. Implement automation. Yeah, I think I did do this. The automation must have been a repeat. So automation again is quite good. So the next thing is managing your dependencies, because dependencies, they are quite important. You have your node packages, npm, is it? Yeah, JavaScript packages. If you're using Python, your Python modules. Some of these modules do have vulnerabilities occasionally. It's always good to monitor them, monitor your dependency and see, is there any vulnerability in one of your dependencies? Like a common one, we have the one that had come up so recently. We had the log4j. This was basically in Java. It was quite a critical one. And basically, though a patch was then available, but you even find that even after the patch was available, 3-4 weeks later, even a month, not everyone had patched the system despite being a critical vulnerability. So this is what we're talking about. Manage your dependency, look at them. If you have them, patch them. If you get one of those security alerts, try to upgrade them. Yeah, for Java guys, I know it's always quite hard to upgrade your application because Java is quite complicated, but yeah, you still have to do it because you need to build securely. So your dependencies, that basically once you look at them, it'll be good to go. Oh yeah, you also need to evaluate and improve. So assess how the process is working, and then look at which are the key areas which you can improve. For example, you find that when building, we're getting so many alerts based on this issue, maybe some of the dependencies from this project, then maybe look, is there more secure, stable alternative to this dependency? Instead of every time having to update it or maybe patch a security vulnerability, because some get vulnerabilities more often than others. So you try to look at the alternatives, and so as to avoid every time you're always fixing something on your production code, so that you can get something that is more stable for the long term. Also collect data. Data is actually important. It will help you to know if there's an issue. In case of anything happens, that I will try to tell you what is going on and what went wrong. Yeah. So some of the challenges that are in the DevSecOps implementing that people do find, we do have lack of security assurance at business and project levels. So this is basically, there's uncertainty about the adequate of appropriate of security practices for business or project needs. Find that the security requirements are not exactly defined in some of these projects, so you do not really get to access the correct to build securely with all the correct measurements in line. So one of the approaches you can do is assess the industry specific security requirements. For example, if you are in the health sector, I'm talking about health sector much because I've dealt with it quite a lot. So if you're in the health sector, look at what are the compliance, the ISO standards required for medical issues. Look at them, look into them, and then ensure you are compliant with these. With some of the regulations, the GDPR, I think the FEPA, yeah. Look at it, and then are you compliant? Have you fulfilled it? And you just go about with it. So the other one is the organization barriers when it comes out to collaborating, tooling, and culture. Yeah, some of these organizations find that well. It's quite common. It's quite common. You find that the collaboration is not really there. So you find that everyone does their own thing at the same time. So you find that the developer does the building and then writes a nice README for the person who's going to deploy to follow the process. Then the person who's in charge of deployment just comes, follows the procedure. Then, so if there's a problem in the code, the person who's deploying will just deploy as is. So it's quite an issue, and sometimes it's expensive because you require additional personnel for this, or the job description for one developer, sometimes one of your teams will maybe go above and beyond what maybe was in the job description. But it's a small issue. It's not really a big thing. But you can, like I said, you can start small and then you can document the process. build collaboration. Then with time, it becomes a culture whereby it's now not something new into the industry. It's something that's a culture. So if you bring in new developers or a new team, they find that there's already a culture of DevSecOps in place. So all that will be going on is just catching up from there. So it does not look like it's extra work. It just looks like it's part of the job. So the next thing you can do an impact to quality. So this basically security teams are mostly involved too late. You find that in most cases get involved when there's already a breach that has occurred. Maybe you've realized maybe there's an intent of compromise. That's when you start finding you're not being called upon to maybe try to look at it. But if you start improving security early from the ideation stage, you're building this app, this is what you want. Call in a security guy, let him maybe look at a few things, give a few pointers. When you go to the design phase, call the security guy in, let them give a few pointers, and along the development process, this is our development pipeline. How do you think? You find that some of these things will be eliminated basically. You'll not be having some of the issues that will be coming on. Sometimes being hackers is normal, but the thing is, we try to make it as hard as possible for the hackers. That's the whole goal. We can never be 100% secure. Yeah. So the next thing, we have the lack of confidence in the release, and then system complexity. I'm just going to comment because they're kind of a bit in a way. So the complexity and the lack of quality is because sometimes you do find that, wow, you have like one application or maybe like a company on the entire like deployment, they have like hundreds of containers with different endpoints all working together, that there's the 100 like virtual networks, there's a few load balancers in between, and then you have lots of API endpoints working together, and this is quite a challenge to keep track of, because you find that there's a few networks in between, there's a private network, several public networks, or interfacing with like maybe one or two or three, maybe four different applications. Look at maybe the deployment of like 100 containers or maybe thousands sometimes of containers deployment. Some goes even further extensive, because you find that desktop applications, you find that maybe hundreds of desktop also involved. So you have to like keeping track of all that basically in the production. It's quite a complex task because it's quite a lot of things to be on the lookout for. So yeah, so that basically it's basically there's no really, the approach for that is basically from the DevOps pipeline, maybe try to look at the security in it, and as you go about it, you'll find that some of these things, even though it's quite complex, you find that some of these issues will be mitigated, because now you have basically you have a good documentation, all the assets are properly and easy to manage because there's a good accountability for the assets. And then you also find in security, there's now the accountability and authorization. You know who has access to this, who's in charge of this. It's not like whereby one part of the production has failed and you're like, who's supposed to fix this? Call this developer. The developer is on another code base, on a different code base. So, but then when you have clear guidelines on who's supposed to be working on this, even a complex system gets to become easier and easier to manage, because that's the whole point. The other thing is the lack of security skills. Yeah, this is quite a big one, because in most places you find that there's no dedicated security person, and basically it's the head of IT who's in charge of security, and he's not fully trained for security. It's because he's the head of IT, is basically it's his job description, but when security wise comes, he's not fully trained or equipped for the task. So it's quite a big deal, and you find that, and also getting a security person is not really cheap, and for most organizations it's quite a lot, and having maybe a dedicated security person. So, but if you can try to implement some of this, basically everyone has a security skill, and maybe like get someone from outside consult, maybe an outside consult, maybe once in a while to come for consultation. It will help increase security while minimizing the cost from the business. Things like the MSSP, managed security service providers, you can engage them because it's cheaper than hiring an in-house security person who's basically be looking at your security posture, come in, help analyze and look at your production. You also sometimes get, it's not maybe one person, it's a team that you do get. And the other thing is the insufficient security guidance. This is actually quite common here in Kenya, because you find that in some cases it is there, but actually some of these laws are there, even in the constitution, but it's not well known by people. So you find that it's more of a laxity from our end, more than the government or the security responsible measures, I think the also the protection officer. So you find that some of these issues, it's not really they are there, but they're not really well known. You find that if you go to most people, find if you do ask them about it, well, not many people have an idea about it as much. They only have, it's supposed to be secure, but if you do ask what's the security you're talking about, no one can hack. But what are you exactly preventing? Because there are quite a lot of bugs that you'll be looking at, and you need maybe to let them know what they're building against. The OWASP top 10, the SANS 25, which are the common ones. So the developers need to be aware. These are some of the things that we are looking for, and so they're not there in the development. This is how you can prevent them. Even when they're building, some of these things are already eliminated by default because everyone is aware of what they'll be looking at. Yeah, and that's the end. Sorry for the memes. Programming Humor channel on Reddit was not really available to me at the moment. So, any other question? Any question, Ali? From the, okay. Okay, so thank you guys, and that's the end of my presentation.